Hello guys, so we've done a lot of chapters. We are really pushing and the piece. So now we'll be doing probability, right? So it like just like calculus, not just like calculus, just like financial maths, it will be a two-part series. Probability, right? So probability is all about chance, right? It's all about um yeah, it's all about chance, right? So the probability, what will happen is that in this first part, I will give you probability that you have to move from grade 10 up until you grade 11, what is important. And then in the second part, that is where we will do what is introduced in grade 12, which is accounting principles. And then by so doing, we'll be done with probability, right? So in probability, it's all about in events, right? So it has a couple of formulas and a couple of rules that you always have to know. And then once you have that, it's not a problem. It's just a matter of reading the statement and then understanding exactly what you've been told, right? So in probability, as I said, it's all about chance. They will ask you what is the probability of flipping a coin and it landing on the head or the tail and stuff, right? So it's all about the possible outcomes always and the favorable outcome that you want, right? So basically, this is the formula of probability. The probability of an event is equal to the number of times the event is occurred, right? So it is equal to the number of times an event is occurred. Most of the time, they will use the number of elements. If they use this n, it's before number of elements, right? So they will tell you the number of elements, the what we call the number of possible outcomes the event can occur all over the number of the possible outcomes, right? So this E is for an event, this S is for your sample space. So what is your sample space? Your sample space is the possible outcomes, right? Everything you have, the possible outcomes, what can you get, right? This E is the favorable event. The E can be A, it can be B, right? It just represents an event, right? So this one of n, they mostly use it most of the time when you have number of elements. Let's assume that they gave you something like this, and then they give you something like that, right? So they ask you how many elements you have. You have 3 elements here, you have 3 elements, right? So that is what we are talking about when we're talking about this n. It's for number of elements, right? But they don't use it most of the time, right? So that is basically probability for you. But this is what we call the theoretical probability. That's what we call experimental probability. In experimental probability, the probability of an event is given by the number of times the event has occurred already, right? It has occurred, number of times event has occurred, right? All over the number of trials done, right? So this is not grade 10. They won't ask you what is a trial. They won't ask you the experimental probability, right? Those are just the basics. I'm just reminding you, right? So you have to familiarize yourself with all those things. And then while we are still on that, there are other things that we have to know, right? There's this symbol we use that is just like a U. We call it a union, right? The meaning of this is just simply or, right? It is or. So there's this other one which is like an upside or an inverted U, which we call an intersection, right? So your intersection is simply for end, right? That is where you have maybe event A and event B sharing the some of the elements in that video intersection, right? I hope that makes sense, right? And then from there, obviously, I told you that this E can be substituted with A or B just to represent whether it's event A, event B, and so forth, right? So there are things that I want you to be familiar with before we can even go to the formulas and everything, things to quickly remind you of. This simply means the probability of event A happening, right? Or we can say the probability of event B happening. When you see these notations, it's probability of A and probability of B. There's this one probability of A, right? This is probability of A or B, right? Or sometimes they write it in full like that, right? Probability of A or B. And then we have this other one, which is like that. This is probability of A and B, which can also be written in full as probability of A and B. And then we have this other one, which is like that. This one is probability of B happening, assuming that A has already happened. I will repeat, it's probability of B happening, assuming that A has already happened, right? And those are the things, basic things that you should know, and then I think you should be sorted because they don't really ask anything besides those ones, right? So those are the notations they use. So while we're still on probability, we know that probability ranges from 0 to 1, right? Probability is ranges from 0 to 1. If the probability of something is 0, we say that it is impossible, right? It won't happen. If it is 1, we say that it is certain. It will surely happen, right? And then we have 50 in the middle, which is your 50% chance of that thing happening or not, which is where the one of flipping a coin comes here, right? The one of flipping a coin is a 50% chance because it has only two sides, right? It's either you get that one or the other one, right? So let's say you are saying when you go to a restaurant today, they will give you food for free, right? That one, the possibility is it's impossible, right? There's no way you won't pay and then you get food, right? So it's zero probability. And then let's say now you're saying that if you study and practice maths every day, you'll pass maths. That is certain, right? That is certain, it's 100%. You will pass maths. We don't care how you pass maths, but you will pass maths, right? So those are some of the things, right? And probability can be it can be expressed in terms of the whole numbers, just like in this case, 0, 50, and 1, or it can be expressed in terms of percentages. Obviously, this will be 50%, that will be 1%, right? And then it can also be, that will be 100%, I mean to say, and then it can also be expressed in terms of decimals, which can be 0 0.0, 0 0.5, and 0 1.0, I mean to say, right? So those are the just basic things that we have to know. So while, now that you understand all the basics and everything, there are certain rules that you have to understand, right? The first one is what we call the mother rule, right? Or what we call the addition rule, right? So this is the addition rule of probability. The addition rule of probability says that the probability of event A or, right, event A or B, right? The probability of event A or B is equal to the probability of A plus the probability of B minus the probability of A and B, right? This is the addition rule. Now, while we are still on the addition rule, it sometimes happens that the events don't share the elements, right? And we say that those events are mutually exclusive. So when we say that the events, we explain this in terms of Venn diagrams, we'll go to Venn diagrams, but remember if this is event A and this is event B, right? You can see that they share this in the middle, right? So when events are like this, we say that they are mutual, right? But if the events are like this, it's event A here and it's event B, they are not sharing any, elements. We say that that mutual relationship they had is excluded. So we have to say that these events are mutually exclusive. So it means that the probability of A and B, there's no A and B here. So the probability of A and B will be 0. So every formula will derive it from here. So for mutually exclusive, you must know these things because they might tell you in the statement that events are mutually exclusive. But if you don't understand what is mutually exclusive event, you won't be able to answer that question. So we know that if we derive the formula for mutually exclusive events from the mother rule or the addition rule, it will be that the probability of A or B is equal to the probability of A plus the probability of B. It ends there. Why? Because the probability of A and B is 0 because they don't share anything, right? And then we have what we call the exhaustive, right? The exhaustive events, right? When events are exhaustive, when something is exhausted, when you say you're exhausted, you simply mean you are tired. You've used all of your energy. You don't have any energy left. So when we say that the events are exhaustive, we mean that they've used all of the sample space. There are no other possible outcomes left, right? They've used all of the sample space, right? So when events are exhaustive, we simply mean that those events have used all of the sample space, right? They've used all of the sample space, right? That is all that I can say. They've used all of the sample space. So meaning that when we add all the possible outcomes, they should give us 100% or they should give us 1. That is what we're basically saying, right? And then we have what we call the complementary events. Complementary, when you compliment someone, you can't say to someone, you are beautiful, and then you say, you're beautiful, but your ears are pink, or you're beautiful, but I don't like your eyes, or something. That is no longer a compliment. When you compliment someone, you give them 100% assurance that I like this thing. You must be confident with that thing and everything, right? So when we say events are complementary, we say that those events, when you add them up, they should give you 100%. So here, I know that it sounds like the explanation of the exhaustive, but this is what you must know. For events to be complementary, they have to be exhaustive and they have to be mutually exclusive, right? For an event to be complementary, for you to conclude that an event is complementary, it has to be mutually exclusive and it has to be exhaustive, right? It has to be mutually exclusive and then it has to be an exhaustive event. If it's not mutually exclusive and it's not an exhaustive event, then we can't conclude to say that that event is complementary. So remember, I said that when you say something is complementary, you give it 100% assurance. So it means that we want the probability of A and B to give us exactly one. We are complementing it at 100%. You are good, right? But now this is what we have to. If you have two events, event A and B, if something is not event B, it will be event A. If something is not event A, it's event B, because we only have those two. And we said that they're mutually exclusive. So we can't say this none that doesn't follow this. If it's exhaustive, it means all the possible outcomes must be found in those two. I hope I'm making sense. So what I'm saying is that if something is not, probability of B is the same as probability of not A. Because if something is not A, definitely it's B, right? So probability of B is the same as probability of not A, right? I hope that makes sense. So meaning what I'm basically saying is that this is the same as probability of A plus probability probability of not A. Or I forgot to give you this. When you put this, remember when we were deriving in calculus, this meant derive. This side means not, right? In probability it means not. So this is the same probability of A plus probability of not A. If it's not A, it's probability of B. Why are we saying so? Because we said that the events are exhaustive. So if that's the case, we are basically saying that the probability of not A is the same as 1 minus the probability of A, because we take this to that side. So this is the formula for what? For exhaustive events. I hope that makes sense, right? That is the formula for exhaustive events, right? And then we have what we call the independent events. Independent events, it happens sometimes that they tell you that you in a bag you have so much balls and you take out those balls and then you don't replace or whatever, right? So for independent events events are two events that do not affect each other. They are independent. So meaning that, let's say in your, let's say you have a bag, right? In this bag you have balls, right? You have 2 red, you have 4 blue, you have 6 green, right? And then it happens that you close your eyes and then you put your hand at random, you choose 2 balls. If you take 2 balls, any 2 balls, and then you return them back, right? Let's say you want to take 2 blue, right? And then you return them back, and then your second event is to take maybe a red and a blue. The second event is not affected by the first one if you return back the balls, right? So if you take the balls and then you return them back, we call that the independent events. So for your independent events, how do you prove that events are independent? The probability of A, look again, the probability of A and B is equal to the probability of A multiplied by the probability of B, right? So this is the formula for events that are independent. So if we are saying that the independent, the formula, what we call the events are dependent, it means that for your first event, maybe of taking 2 blue balls out, you take them out, but you don't return them. So we can see that in the first event of you taking the blue balls out, initially you have 12 balls all in all, right? So your probability of taking out 2 blue balls out of all these balls will be 4, because you have 4 of them all over 12. That will give you something like 1 all over 3, right? But if you take if your first event you take out those 2 balls and then you don't return them, So it will be 12 minus 2 because you took them, you didn't return them. Now it means your sample space is now 10. So you've affected it. You can see that the second event of you getting the red and the blue ball has been affected by the first one, because now the sample space is no longer the same. So that is what we mean by independent and dependent events. So it means that in when the events are dependent, the second one depends on the first one because of the sample space, right? So it means that the dependent event, you don't have a formula as long as the probability of A and B doesn't give you the product of A and B, and then you can conclude that those events are dependent. They are depending on each other, right? I hope that makes sense. Sorry about that, people. Someone needed something. So now, what do you have to know now that you understand all those formulas I gave you and everything? What is important in probability is they won't always give you things that will ask you. All those formulas I just gave you, you will apply them somewhere. So probability, they will always ask you in terms of either tree diagrams, right? We can represent it with tree diagrams. We can represent it with what we call the contingency tables. We can represent it with what we call the Venn diagrams. So I'm going to quickly go through all those, and then that will be it, right? So I'll show you what is it that you have to know in tree diagrams, what is it that you have to know in contingency tables and Venn diagrams. And probability is just like the financial maths, right? If you don't understand the statement, if you don't understand the English being used there and you don't read carefully, then it's a recipe for disaster, right? It's a recipe for disaster, because then you won't be able to correctly answer what you are being asked. So I won't go through each and every example and give you each and every example because the video will be too long. What do you have to know when it comes to tree diagrams? I'll simply use the example of flipping a coin and rolling a die, right? So when you flip a coin, that is event A, and when you roll a die, that is another event, right? So let's say that the first event is you flipping a coin. So when you flip a coin, or let's say either way, right? Either way. Let me say you roll a die. Obviously, the die has 6 possible outcomes. So it's possible outcomes, 6 of them, right? So I want to show you something. 1, 2, 3, 4, 5. So it's 1, 2, 3, 4, 5, 6. Right? This is your first event. You roll a die, right? So after that, the second event is for you to flip a coin, right? You know that the coin has 2 sides, so it's either you get a head or you get a tail. The second one also get a head or you get a tail. The third one also head, tail. Fourth one, head, tail, head, tail, right? Head, tail, right? So now we can see that your possible outcomes, all of your possible outcomes, all in all, you have 12 of them, right? How do you see your possible outcomes? You count the last one, right? All of them, it's 12 of them, so that is your possible outcomes. But now, this is what you have to work on the tree diagram. Here in these lines, you write your probabilities. So what is the probability of getting 1? Obviously, all of them here will be 1 over 6, 1 over 6, 1 over 6, 1 over 6, 1 over 6. All of them here, because if they say what is the probability of getting a 6 when you roll a die, there's 1 6, right? So how many possible outcomes? 6 of them. So that is why all of them will be 1 over 6. So you must always write your probabilities here. What is the probability of you getting that? That all of them will be 1 over 2, 1 over 2, 1 over 2, 1 over. You can't say 1 over 12 because this is one event. This is one event. This is one event, right? But what you have to know is that each event should give you 1, right? So 1 over 6, 1 over 6. If you add all this 1 over 6, they should give you 1. This 1 over 2 and 1 over 2 obviously will give you 1. That one and that one always will give you 1. Now, this is what I want you to understand. This is what is important. Right? They can ask you any other questions, but it comes back to what I'm going to tell you. If they ask you the probability, okay, let me just say this. If you're going sideways, you multiply. If you go down, you add. That is all that you have to do. I repeat, if you go sideways, you multiply. If you go down, you add. That is all you have to do. And always, when they say to you the probability of something and something, you must always multiply. This is for your end. When they say the probability of or, the moment they say or, that is you adding, meaning you have to go down. Now they can use both. They can say probability of and sometimes they use one, but you have to understand. Hence I said it comes back to you reading the statement correctly. Now, let's say they tell you to find, or they ask you what is the probability of getting a 1 and a head, right? The probability of getting 1 and, right? They said and, probability of getting 1 and a head. I told you that when they say and, you use multiplication. So what is the probability of getting 1? It's 1/6, right? So probability of getting 1 is 1/6. What is the probability of getting a head? 1 and the head is 1/2. So you have to multiply because you are going sideways. You didn't go down, you're going sideways. So you have to multiply that. What will be the answer? The answer will be 1/12, right? The answer will be 1/12. If you wanted to find, okay, I only have 1 there, right? So ahead, I told you that the possible outcomes will be 12. So you didn't have to calculate them. You just multiply. You now know that it is 1/12. Now, let's say they ask you, what is the probability of getting an probability of getting an even number and head, right? Probability of getting even number and a head, right? So we know how many even numbers do we have? It's 2, 4, and 6, right? And then for each 2, 4, and 6, all of them it's 1/6, 1/6, 1/6, and then we must get a head. So it's 1/2. It's the first even number we have, it's 1/6. I want to show you something. The first one, it will be 1/6. That is the probability of getting an even number, which is the first one is 2. Multiply by getting a head, that is half, right? Half. And then I have to add that. Why do I have to add that? Because where is my second even number? It's here. So it means from here to here, I went down. So I said when you go down, you add, right? That is how simple this thing is. We said the first one, they said probability of getting an even number head. Even number head. I go sideways and multiply. 1/6 multiplied by 1/2. Now I'm going down, but for the second even number, I'm going to add. Add what? What is the probability of getting 4? It's 1/6 multiply probability of getting a head, that is 1/2. Plus, why am I adding? Because the third even number is here, it's down. So again, it's 1/6 multiplied by 1/2, right? So you see that you have 1/12 plus 1/12 plus 1/12, which is going to give you what? 3/12. It all comes back to the possible outcomes. It will always be 12 because all of them are 12, right? So that is how they can trick you. I'll try to find examples to give you, but it all comes back to that, right? It all comes back to that. Now, I don't want the video to be too long. Let me go to contingency tables. With your contingency tables, they will give you a 2x2 table, right? A 2x2 table. You will have something like that. You have your total here, you have your total here, right? Let's say they ask you, you have people who, what can we compare? They tell you that you have people who are rich and people who are poor. And they tell you that the ones who are rich, they always, they either, let's say, they either buy a BMW, and let's say others by let me just say Toyota, right? They want to see the relationship of someone being rich and buying a Toyota, or someone being poor and buying a BMW, right? So most of the time, what they will do, they will maybe give you the total. Let's say the total here is 50, right? And let's say the total here is 100, right? And they tell you that this is, let's say, letter A. They tell you that the total of this one is 7. They tell you that that is X, and they tell you that you have 40. They tell you that that one is Y. This one is C, and yeah, and then they tell you, let's say, this one is 20, right? So they will ask you firstly, find Y, C, what, or find those letters. It comes back to this row must give you this total. This row must give you this total. This row must give you this total. This row must give you that total. It's easy. So obviously, for you to find C, you'll simply say 70 minus 40. That will be your 30. It means there's 30 there. For you to find Y, it's 50 minus 40, because when you add these two, they must give you 50. So Y must be 10. Now that you found this one, 30 plus 20 should give you 50. Is it correct? How do you know? Yes, because 50 and 50 are giving me 100. And for you to find this one, you can say 10 plus 20, that should give you 30, or you can say 100 minus 70, that will also give you 30, right? Now we are sorted with all these letters. We now know the numbers. And then they ask you, what is the probability of someone being rich and driving a BMW? Now, here with the contingency tables, it's all about reading the statement and understanding it properly. When they say someone is rich, this is the column for being rich, right? So meaning you must focus in. And they tell you probability of someone being rich and driving a BMW, right? Rich and driving a BMW. So obviously it's 40. But now the question is it 40 over 70 or 40 over 100? That is where it, a lot of people get lost, right? So that is what you must really, really understand, and make it a point that you read your statement correctly, right? Make it a point that you read your statement correctly. The only way to master this is to do a lot of examples to see how they structure these things, right? But for this one, in this case, they said the person is rich, right, and driving BMW, right? They didn't say that among the rich people, né? If they said among the rich, will go with 70. So with all these people here, we want the probability that that person that you're picking at random is rich and driving a BMW. So that will be over 100. So let me say to you, we go back to the same statement. They say to you, what is the probability that the person chosen at random is a rich person, right, who's driving a BMW? So that will be 40 over 70. I know it sounds the same. Hence I'm saying that I'm going to look for examples to show you exactly how they structure this, because they sound the same, right? I'm going to show you how they structure those questions so that everything makes sense. But it all comes back to that. It's very, very simple, right? Or let me rather say I don't know how to let's say they tell you that the probability of being rich, or not the probability, let's say they say to you, being rich and driving a BMW, those are independent events, right? Being rich and driving a BMW are independent events. So the question then is, what is the probability of being rich, right? What is the probability of being rich? The probability of being rich is 70 all over 100. What is the probability of driving a BMW? probability of driving a BMW is 40 all over 50, right? The probability of driving a BMW is 40 all over 50. No, it should be over 100 good people, because they didn't say, because these are people who are driving BMW. It's 40 of them, out of all these people, right? Probability of driving a BMW, it's 40. No, it's supposed to be 50 now. Sorry. Yeah, you see what I'm talking about? It's supposed to be 50. Why am I saying it's supposed to be 50? Because we don't care at this point whether that person who's driving a BMW is rich or poor. The person is driving a BMW, so it's 50 of them all over 100. So they tell you that these two events are independent. What happens if events are independent? When you multiply them, you're supposed to get the probability of A and B, meaning you're supposed to get the probability of the person being rich and driving a BMW. Right? So this question is just coming from the top of my head. So some of the things, when you try to work them out, they might not work out correctly. So I'll try to find examples, right? But I just wanted you to understand what contingency tables are all about. Now, let's quickly go to the Venn diagrams, right? The Venn diagrams, they don't entertain much of the grade 10 and Venn diagrams. They entertain mostly the ones which have 3 events. But this is what you have to know with Venn diagrams, right? This is the easiest way my teacher used to teach me. Let's say you have 2 events, right? If they say the probability, obviously, you must always have your sample space, right? Your total, you must always have your sample space. And you have your event A and B. If they tell you that, let me do this. If they ask you for probability of A and B, you focus here only. This is for probability of A and B. If they ask you for probability of A or B, A or B, you focus in everything, right? In everything. Good people, I can't shade for everything. I really can't shade for everything, right? But I really hope what I'm saying makes sense, right? Now I drive, good people. This is for probability of A and B. You only focus on that section. If they say probability of A or, this is for probability of A or B. You focus on both. If they say probability of B only, right? B only, right? This is where you focus at. If they say probability of neither A nor B, right? Neither A nor B, so it means none of them. So you focus on the outside. If they say probability of B, they didn't say B only. They said probability of B. You will include this, right? So sometimes they will say for this one, they will say maybe probability of not B, right? If it's not B, obviously it's A, right? So you must just get used to those. But as I told you that they won't use this most of the time. What they will use is the one of 3 events. So when it comes to Venn diagrams, for the one of 3 events, your events can be either like this and then the other one is excluded, or all of them can be excluded like that, or all of them can be included like that. This is the one they like most of the time, but that doesn't mean that they won't utilize this one and that one. And it's painful that a lot of students, they always assume that this one is the one that they will ask you about. It's not the case. What will guide you whether you should draw this one, that one, or that one? It's the statement. If in the statement they say maybe all 3, right? They tell you that maybe all students, there are 5 students who are taking all 3 subjects. If they're saying all 3, then it means all of them should combine, right? If they say maybe they didn't, you must just read your statement, good people. That's it, right? That's really it. Now here, what you have to know, most of the time they won't give you one part, right? And you're supposed to calculate that. You indicate that with X, right? So that is what will happen most of the time, and you are required to calculate that, right? So the video is already too long for people, and I feel like it's going to be a waste of time if because it's a lot of data. So what I'll do, because the Venn diagram was the last thing, and then we go to the counting principles. What I'll simply do, I'll try to upload a video on YouTube. And I've been saying this, but I'm not getting a response from you. You tell me if that's okay with you. And then what I can do, I can do examples of these things with short videos on YouTube and upload so that you understand. So that will be it, good people, for the probability of grade 10 to 11. It's really easy. The only one that is tricky is this one in the contingency tables only, right? But it's pretty simple. And they don't bring contingency tables most of the time in grade 12. But when they do, it's a bit tricky then there. But this one is the one they like, right? They will always bring this one. So you must know. Now, I can tell you simple things that you have to do. If they ask you what is the probability that, let's say this is event A, event B, and event C, and they ask you what is the probability that the person at random is only interested in at least, they say at least one event. If they say at least one, if they say at least one, this is what you do. You take your sample space. Obviously, you have your sample space. That is the total outcome. Let's say it was 150 people or something. You take your sample space, you minus, I repeat, you take your sample space, you minus all of these events, right? You minus all of those events. The one that is left, that is at least one, right? Meaning that when you combine event A, B, and C, when you combine, I don't want to say A, let me say A or B or C, right? Sample space minus probability of A or B or C, meaning you have to add all of them. When you minus that is the probability that the person at least likes one. I don't know if this makes sense. And then when they say at least two, this is what you do. When they say at least two, you add this, what you find here, 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 and there, right? What you find here, 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 and there. You add all those all over the sample space. That is at least two. When they say none, you take whatever is here all over that. That is your probability. But as I said, I will look for examples and I'll do that on video on YouTube or something until you understand. So that's it for this part, good people. Thank you.